In this video, we're gonna do some practices on chain rule combined with quotient or product rule. So let's start with the first question. We have y equals x cubed plus 1 multiplied by radical of x cubed minus 1. So we have product rule here. I will consider the first one to be f and the other one to be g. So the whole radical is g of x. If you don't remember what is the derivative of f times g, the product rule is f prime times g plus g prime times f. Now, so what is f prime in this case? I look at the exponent of the parentheses outside. There is no exponent. It means just do the derivative of x cubed plus 1. And in this case, f prime will be 3x squared only. The 1 will become 0, so that's why it's only 3x squared, multiplied by g, which is x cubed minus 1. So this is the first part, plus. The other part, I need to do the derivative of g, which is the radical x cubed minus 1. Now, if I look at it on the side, it's always better to do this on the side. So it looks like radical of u, and we know the derivative of this will become u prime over 2 radical of u. This is the rule I said in the previous video. So u prime in this case will be the derivative of x cubed minus 1, which is 3x squared, over 2 radical of x cubed minus 1. So basically this is our g prime. I'll write it there. Multiplied by f, which is x cubed plus 1. Now I try to simplify. If I have anything here for the first part, no need for parentheses because it's just multiplication. And for this one, if you want to multiply or distribute, you should write this parenthesis in the numerator, because the multiplication, as if you are doing over 1, you multiply numerator by numerator, denominator by denominator. So this will become 2 radical x cubed minus 1, and on top 3x squared multiplied by x cubed plus 1. Now we cannot simplify anything here. The only thing we can do is to distribute for numerator and get the final answer. If they ask you in any of the questions to rationalize or give your answer without radical in the denominator, so you need to remember that we should multiply up and down by the same radical. The 2 is not related to the radical, so you can multiply up and down and finalize your answer. Alright, just a quick reminder. Here we have addition in between, so you're not allowed to simplify something like this. Okay, never do that. Only we can simplify something in the numerator with anything in the denominator if we have multiplication between the fractions, or we have term multiplied by a fraction, so it should be multiplication. Alright, another question. So here I have a quotient, I have something over something. In this case, I should remember the quotient rule. The derivative of this is f prime times g minus g prime times f over g squared. So the derivative here will be f prime, it means the derivative of the numerator, and g is the whole denominator, which is radical of x squared minus 1. So derivative of f is 2x multiplied by g, so multiplied by radical x squared minus 1 minus. Now what is g prime in this case? G prime is the derivative of radical of x squared minus 1. But again, this will look like radical of u. So to find the derivative, it's u prime over 2 radical u, which is 2x over 2 radical of x squared minus 1. Always it's better to do it on the side. Then 2 and 2 here, we can cancel them because 2 times x over 2 times radical, so the 2 and 2 we can cancel them, and I get my final answer for g prime to be x over radical x squared minus 1. So this is the g prime multiplied by f, so multiplied by x squared. As you can notice, I didn't write the x squared here next to the radical. It's multiplied by the fraction. Okay, so don't multiply it down. Over g squared, which is radical of x squared minus 1 all squared. Now let's try to simplify our answer. 2x multiplied by this, it stays the same, minus. For the first one, you can write 1 in the denominator. Multiply, you get x cubed over radical x squared minus 1 over. Here you can simplify these, and we get x squared minus 1. You can keep it in parentheses or just x squared minus 1. That's totally fine. Now, to simplify more, in the numerator we have something minus a fraction. So you cannot subtract unless you have the same denominator. So what I will do is to write over 1 for this, and I should make common denominator. So I should multiply by the other one, which is radical x squared minus 1, up and down. What do we get in this case? 2x is 2x, radical of x squared minus 1 multiplied by radical x squared minus 1. It will become radical x squared minus 1 all squared. So it becomes like this when you multiply by itself, right? Then the square and the radical can cancel. We get x squared minus 1 only. Now, because we have the same denominator, I will write it in one fraction. Minus the other numerator is x cubed. So we could subtract because we have the same denominator now. Now, from here to the next step, I think I mentioned this in one of the videos before. If you have fraction over a denominator, you are allowed to bring the b directly next to the c. So it becomes like a over b times c. And this is what I will do here. So I'll bring the radical down. I will get x squared minus 1 multiplied by radical x squared minus 1. If anyone is asking why did I write the parentheses before the radical, it's totally fine. You can write the radical first, the parentheses after, because multiplication is commutative. You can swap, as if you are doing 1 times 2 is the same thing as doing 2 times 1. And on top you can simplify, you can distribute, you get 2x cubed minus 2x minus x cubed. To simplify more, two x cubed minus x cubed will be only 1x cubed minus 2x, and that's it. In some cases, maybe we can take x as common factor on top, and we can notice we have x squared minus 2. I didn't do this step here because I'll show you. There is nothing to simplify. But if you can simplify, maybe this parenthesis was x squared minus 1 over x squared minus 1. In this case, we can simplify, but just this is your final answer. If you want to rationalize, as I said before, we multiply by the radical up and down and so on. Next question, we have product. This is our f and this is the g. So using the product rule, which is f prime g plus g prime f, I can see that f is something in terms of x with an exponent. So let's do it on the side. So let's do f prime on the side. We bring the 4 down. 2x cubed plus x exponent 4 minus 1 will be 3. So I stop there. This is our u of x. So I bring the exponent, then I will write u exponent n minus 1, which is 3 in this case, but I should not forget the u prime. So I should multiply by the derivative of what is inside the parentheses. So 3 times 2 in this case will be 6, x exponent 2, plus derivative of x, I don't know why, most of the students, they forget it. It's plus 1. You take the coefficient of x, which is the one that we didn't write. Alright, if I want to do it more, I will multiply the 4 with the 6. So if I want to write in details, as I said, it's better to write the parentheses with an exponent at the end. Here you can distribute the 4 if you want, only over the first parenthesis. Here you're not allowed to do this because we have an exponent, as I mentioned before. So now our final answer will be 24x squared plus 4 multiplied by 2x cubed plus x exponent 3. So this is the f prime. Let's do g prime on the side. It looks like radical of u. So this is the u, right? So to finalize our answer for this, we need to apply the rule u prime over 2 radical u. So g prime will be 2 radical u down, so x squared plus 2x, and this is the u. We need to multiply on top by u prime, which is 2x plus 2 in this case. If I want to simplify more, I notice there is a 2 in common. I take it in common. And now because it's all multiplication, you can simplify this 2 with this 2, and your final answer will be x plus 1 over radical x squared plus 2x. So this is the g prime, and this was the f prime. Now, to find the derivative of y, you do f prime g. So what we wrote on top, this is the f prime, times g, which is radical of x squared plus 2x, plus g prime, which is x plus 1 over radical x squared plus 2x, multiplied by f, which is 2x cubed plus x exponent 4. Usually when they ask you about these questions, they will not ask you to simplify. But if you want to simplify, you should notice that here and there is 2x cubed plus x exponent 3 and 4. If I want to take common factor, I should take the one that has the smallest exponent. So I can write 2x cubed plus x exponent 3 as a common factor. I will write it on the right side. What is left from the first is 24x squared plus 4 multiplied by radical x squared plus 2x. This all went outside, that's why I removed it. Plus, for the other one, I have x plus 1 over radical x squared plus 2x. From the 4, we took 3 out. I still have 1, so this becomes 1. Exponent 1, no need to write exponent 1. If you want to proceed, you can write this over 1 and distribute. Okay, if you want to rationalize, again, you can multiply by radical up and down and do it. Usually they don't ask these questions like this long. The last question I will do is this one. To find the derivative of this, it's not product, it's not quotient rule. We can apply quotient for this because we have fraction, no need. We can do it in a faster way. We can apply product rule for this f times g, no need. So in some cases, even if you can do product or quotient rule, no need to do them. Whenever you have a number multiplied by something, just don't use product rule for this. The number will stay the same. And I know the derivative of radical x by itself, as a rule, is 1 over 2 radical x. Plus, the 6 over radical x can be written as 6 over x exponent half. I take it up. it becomes 6 times x exponent negative half. So if you have over radical x, you cannot do the derivative as 1 over 2 radical x. It's only if you have radical x like this. So I will write the 6 as 6. I don't care about it. Let's derive this. So I just rewrote it. I didn't derive yet. Now to derive this, it becomes 6 multiplied by negative half. So I bring the negative half down. X exponent minus half minus 1. So it becomes minus 3 x exponent negative 3 over 2. I'll write it like this first. So I'll write the final answer, which is minus 3 x exponent negative 3 over 2 plus. Now for this one, it looks like u exponent n. U exponent n. To derive it, I need to bring the n down. So 7 down. After that, we write 3x plus 1 exponent 6. But I should not forget that I should multiply by the derivative of the u. So which is 3 in this case. Let's try to finalize our answer. It becomes 5 over 2 radical x minus 3. And for this one, we need to bring it down to make it positive. Plus, you can multiply the 7 with the 3. It becomes 21. 3x plus 1 exponent 6. And we're not allowed to distribute because we have exponent. Now, if you want to simplify more, I'll just explain how to write this on the side. If I want to write it in terms of radical, the number down will go as index of the root, and the number on top will be the exponent inside. But this can be written as radical of x squared multiplied by x. So remember, the index 2, we don't write it because it's square root, which is radical. No need to write the 2. And x squared goes outside here as only x, because it will be 2 divided by 2. This is how we take a number outside, which is exponent 1. No need to write it. Multiplied by square root of x. I will not write the index 2. So basically, this will become x radical x plus 21 3x plus 1 exponent 6. This is your final answer, unless they tell you remove the radicals. You multiply up and down by radical x, and then you will get your final answer.